This question is from the topic binomial theorem or binomial expansion. Here in this question they have stated that the coefficient of the term x squared from the expansion of 1 plus x over 5 whole to the power n is equal to 3 over 5, where this n is a positive integer. Now, for the first part of this question, they have asked us to find this positive integer n. In order to find this n, we are going to use the formula of binomial expansion, which is known as r plus 1th term. So let me write this r plus 1th term. This r plus 1 term is usually given in our formula page. So let's see how is given in our formula page. Here is the formula page. This is our r plus 1 term, which is, we can say in C, r times a to the power n minus r times b to the power r. So we are going to use this. So let me write this r plus 1th term for r plus 1th term as NCR, let r, then 1 to the power n minus r times we need the second term, that is x over 5 whole to the power r. Let me simplify this a bit, as 1 to the power anything is always 1, so we can eliminate this 1 and we can write r plus 1th term as NCR times 1 over 5 to the power r times x to the power r. Now if you look carefully, the x has power r, so for our x squared term, the value of r must be equal to 2. So let me use this r equals to 2 value in our r plus 1th term. Therefore our x squared term will be NC2 times 1 over 5 squared times x squared. So we got our x squared term, where NC2 times 1 over 5 squared is actually 3 over 5. So let me write, according to the question, it says that this NC2 times 1 over 25, which is 5 square, is equals to 3 over 5. Now this 25 can be divided by 5 and the result is 5. And 5 times 3 is 15. So in the next line we can write NC2 is equals to 15. Now we need to expand this NC2 term in order to get the value of n. But how can we expand this NC2 term? Well, we're going to take the advantage of another formula which is known as NCR, and is also given in our formula page like this, where NCR is equals to factorial n divided by n minus r factorial times r factorial. So using this NC2 term where r is 2, we can write factorial n divided by n minus 2 factorial times 2 factorial, which is equals to 15. Now this, in the numerator, this factorial n can be expanded as n times n minus 1 times n minus 2 factorial, and in our denominator we have n minus 2 factorial times 2 factorial, which is equals to 15. Now from the numerator and denominator, this n minus 2 and n minus 2 gets crossed out. Now we have n squared minus n, which is equals to 30. So now we can write n squared minus n minus 30 is equals to 0. So let me do the middle term factorization. We can write n squared minus 6n plus 5n minus 30 is equals to 0. Now from the first pair, n is a common factor, so let's this common factor out, and we have n times n minus 6. From the second pair, 5 is the common factor, so let's take 5 out, so we can write 5 times n minus 6 is equals to 0. Now we have n minus 6 as the common factor. Let's take it out, so we can write n minus 6 times n plus 5 is equals to 0, which finally leaves us as n equals to 6 or n equals to minus 5. But as this stated, n is a positive integer, minus 5 is not acceptable, so the answer is n is equals to 6. Okay, now as we have completed the first part of the question, now let's move on to the second part of this question. Now here in the second part of this problem, we have to use the value of n that we have just figured out, which is 6, to find the term independent of x, which means that would be a constant, from the expansion of 1 plus x over whole to the power 6 times 2 minus 3 over x whole squared. We need to expand both of these terms, but let us expand this 2 minus 3 over x squared term first. This is a minus b whole squared formula, so using a minus b whole squared we can write 2 squared minus 2 times 3 over x plus 3 over x whole squared, which can be simplified as 4 minus 12 times 1 over x plus 9 times 1 over x squared. As we can see here, this x squared is the highest power in the denominator. We need up to x squared terms from the 1 plus x over 5 whole to the power 6 expansion. So let's write. We need to find 1 plus x over 5 to the power 6 is equals to 1 to the power 6 plus 61 times 1 to the power 6 minus 1. Then we need times x over 5, then plus 6c2 1 to the power 6 minus 2 times x over 5 whole squared, and we know we don't need any more terms. So let's simplify this expansion or these three terms. 1, then plus 6 over 5 times x. 62 is 15, so we can write 15 over 5 square is 25, so 15 over 25 times x squared plus dot 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 dot. Now let's write these two terms in product form. 1 plus x over 5 whole to the power 6 times 2 minus 3 over x whole squared. Let's write their expanded form. So 1 plus 6 over 5 times x plus let's simplify this thing. So 15 by 25 can be written as 3 over 5. So let's write 3 over 5 x squared plus dot dot dot, that will be timed, that will be with 4 minus 12 times 1 over x plus 9 times 1 over x squared. Okay, now let's identify which pair can give us term independent of x. If this 1 gets multiplied with this 4, we get a term which does not contain x. Then this 6 over 5x, if it gets multiplied with minus 12 times 1 over x, again we will get another term independent of x, and finally this last pair. So let's multiply them and add them together. So our x independent term would be, so our x independent term would be 1 times 4 plus 6 over 5 times minus 12 plus 3 over 5 times 9. Let me write 9. So let's simplify this. This is our x independent term, so we just need to do the calculation. Okay, in the next line we can write 4 minus 72 by 5 plus 27 by 5. Let me write it. 27 by 5. Okay, which will be equal to minus 25 over 5. 25 divided by 5 is 5. So finally we get our x independent term, which is minus 5. So this question is done. Now let's move on to the next question.